letters are there. This is from this. Right. How many of you got the idea? Are you getting the idea? Right. I am explaining here. Here, two letters we need to. Event E1, E2, E3 we need to write. So what is E1 is selecting London. E2 is Clifton. So clearly probability of E1 is equal to probability of E2 is equal to 1 by 2. E is selecting on two consecutive letters. Two consecutive letters E. So you look at here in London, what are the possibilities are there? LO is there, ON is there, ND is there, DO is there, ON is there. So now probability of E out of E1. So selecting two consecutive letters that are ON. So 2 out of 5. 1, 2, 3, 4, 5. Now what about Clifton? In this one, what is the thing? CL, LI, IF, FT, TO, ON. 1, 2, 3, 4, 5, 6. So probability of E given E2 is equal to 1 out of 6. Now, what is required? Probability of, I know that visible, ON is visible from London E1. So this is denominator is probability of E and numerator is probability of E1 into probability of E given E1. So probability of E. So you go to E1. So the chance of going to E1 is 1 by 2, then 2 out of 5. Or go to E1 to 1 by 2 and 1 by 2. Favorable case 1 by 2 into 2. So what is the thing? 2, 2, 2, you cancel. Here LCM is 12 plus 5 and here 2 into 6. So 18. Okay. Yes. Moving to the next one. In a factory which manufactures bolts, okay. Machines A, B, C manufacture respectively 25%, 35%, to 40%. Out of their outputs, 5, 4, 7% are respectively the defective bolts. A bolt is drawn at random from the product and it is found to be defective. What is the probability that it is manufactured by machine B? Okay. Yes. Think about this one. Yes. How many of you are getting the answers? Okay, very good. That's good. Many people are. just explaining, I'll explain for the people who haven't got this one. So what is this one? Probability of A is equal to 0.25. Probability of B is equal to 0.35. Probability of C is equal to. Next, what is the thing? Probability of defective from A is equal to 0.05. Probability of defective from B is equal to probability of defective from C is equal to 0.02. Now I got the defective item, but from it is from machine B. So what is this one? By conditional probability of B intersection D by probability of D. So what is this one? Probability of B into probability B by probability of A into probability of B into probability of D given B plus probability of D C into probability of D given C. So you write this one. This is B 0.35 into 0.04 by 0.25 into 0.05 plus 0.35 into 4 into 0.02. You can simplify this. Okay. Okay, moving to the next question. Yes, please look at this one. In a test of, yes, Uday? Srijan?
Sir, sir, in previous question that 5% and 4%, it is out of that 25 and 35 or out of 100, sir.
You should not. So whatever the A comes from, whatever the number of A items are coming, 5% are defective. Okay.
C having a 40% and the defective is 5%. No, sir. Means in 40% it have 5% discount or sorry defective or in 100% it has.
Your way is wrong completely. The way you are looking at that question is wrong. Okay. Because whatever the manufactured A manufactures, then from that one only you will see. Okay.
Yes, sir.
It is whatever the from A lot 2%. So if A is X amounts, X items are they're producing, so it is the items are 5% of that one, 10% of that one only. So how can you look at the overall thing? Okay.
Okay, sir.
Hmm. See, the moment you need to look at that one as, okay, simple. Yes. Look at this one. In a test, an examining either guesses or copies or knows the answer for the multiple choice question having 4 choices. This is completely related to you people when you are writing the weekend exam. You can look at now. Now somebody asking the previous question is seems to be is getting the different answer. So this is what is this one? 2 decimal points cancel everywhere for calculation point of view. Oh, here it will be 2 decimal. This is this one. So it is 35 fours are 140 by 125 plus 140 plus 80 is equal to 140 by 140 by 220, 345. This is what you will get answer. Okay. Yes. Yes, please. How many of you got the answer? This one. In a test and examination, either guesses or copies or knows the answer for multiple choice question having 4 chances. Which exactly one is correct? The probability that he makes the guess is 1/3, and the probability for copying is 1/6. And the probability that his answer is correct given that he copied is 1/8. Probability that he knows the answer gives the correct answer is. So somebody is showing third one is the answer. So probability of he makes the guess is 1/3. And probability of his copying is 1/6. So probability of he knows the answer is equal to, this is what happened, this is 3 1/2, so it will be 1/2. This, what is the addition beta? 2/6 plus 1/6. Yes. Now the probability is answer is correct given that is correct. So probability of the answer is correct even E. What is the probability of answer need to be correct? 1/4, because 4 chances are there. Okay. So now they are asking probability of the probability that E. Oh, no. Here, what is the thing there he has given? The probability that his answer is correct given that probability of answer is correct given that is copied is 1/8. Now he is asking probability of I think I'll write the everything. Now, what is the probability of his answer is correct when he went for the guesswork is equal to 1/4, because this one, and probability of he got the correct answer when he knows the answer will be 1, and probability of he get the correct answer when he copied is 1/8. Now they're asking probability that he knew the answer given his answer is correct. So he got the correct answer. He got the correct answer under when he knows this one, what is the chance? So this is equal to probability of correct the answer. So he can go to guesswork and get the correct answer, or he knows the answer. He knows the answer and got the correct answer, or he copied the answer, he got the correct answer. So probability of n, this one, 1/2 into 1. So this is equal to 1/2 by 1/12 plus 1/2 plus 1/48, which is equal to this is 48, you can write 4 plus 24 plus 1 is equal to 1/8, 1/2 into 48 by 29. So answer is 24/29. Okay. Please copy it quickly. Right. Let me go to, once again explain. See, a student, oh, a student can go for the guesswork 1 out of 3 times. He can copy 1 out of 6 times, and he knows the answer in the remaining cases. That is 1/2. If he's going for the guesswork, what is E is the getting correct answer. So when he goes for the guessing, 4 choices are there, 1 out of 4. So I'm assuming this is a single correct answer only. Now, when he knows the answer, obviously probability will be 1. And when he copies, the probability of getting correct answer is 1/8. Now, the probability that he knew the answer, given that answer is correct. So he got the correct marks. He got the marks for that one. Now, what is the probability that he knew the answer? That's why he scored the marks. So probability of N, knew the answer out of E. So what is the chance of, in how many ways he can get the marks? He can go for the guesswork, or he can knows the answer, or he can copy. Out of this one, what is the favorable case? This is the favorable case. Okay. Moving to the next question. Yes. Please. Yes. Are you getting the answers? Yes, few people are getting that's good. Yes. So anybody wants this answer? A doctor to visit a patient from the past experience known that the probability that he'll come by train, probability of using the train is 3 out of 10, probability by scooter 1 out of 5, probability by others means of transport, maybe any bus or something 1 out of 10. Oh, by train, bus, 1 minute. Oh, wait a minute. Here 4 things are there. So probability of train is 3 out of 10. Probability of bus 1 out of 5. Probability of scooter 1 out of 10. Probability of other means of thing is 2 out of 5. The probability that he'll be late if he comes by train, by bus or scooter respectively. So look at here, what is this sum probability is 1 by 4 plus 1 by 3 plus 1 by 12. So this is LCM if you take 12, 3 plus 4 plus 1. So look at carefully. Probability is late by train is 1 out of 4. Probability of late by bus 1 out of 3. Probability of late by scooter is 1 by 12. Now, what about the probability of late by other means of transportation? Look at here. This is 3 plus 4. This is 7 by 12, 8 by 12. 8 by 12 means 2 by 3. So other means of transport is equal to 1 by 3. You need to write 1 by 3. Okay? Now, then he'll not. But if, oh, right time, just a minute. But if he comes by other means of transport, he will not be late. So it is not there. It's okay. When he arrives, he is late. What is the probability? He comes by train. So probability of late when other means of transport is 0. Okay. So now he is late, I know. What is the by train? So probability of choose train into probability of late when is train by sigma of probability of train into probability of L given T. So this is equal to 3 out of 10 into 1 out of 4 by 3 out of 10 into 1 by 4 plus 1 by 5 into 1 by 3 plus 1 by 3 into 1 by 3. Do we need to require? Not required. So you can get the answer. Okay? This is the answer. Right. Let us move to the next one. Please. How are you getting now some clarity about this Bayes theorem? So how to look at how to convert into subparts and proceed. Okay. In the competitive exam, Bayes theorem is one of the major area. Right, make it fast this question. Yes, how many of you got this answer? No. Okay. Right. Let me explain you. What is it? Suppose that the reliability of HIV test specified as follows. Of people having HIV, 90% of tests detect the disease, but 10% go undetected. Of the people free from HIV, 99% of tests judge HIV negative and 1% diagnosed as HIV positive. From a large population of which only 0.1% have HIV, 1% selected random, given that HIV test, the pathologist report him or her as HIV positive. Okay, what is the probability that person actually have HIV? So this is the probability of having HIV. Okay. Now, probability of test positive when is having HIV is 0.9. Probability of test negative when he is having HIV is 0.1. Probability of test positive when non-HIV people is 0.01. Probability of test negative for HIV negative people is 0.99. From a large population, so probability of H having HIV is 0.01 and probability of HIV not there is 0.99. Now, a person is selected given HIV test. The pathologist reports is HIV positive. So, probability of test positive. Here, what I need to say, the test has come as positive. Given that, okay, this is known. But what is the probability that person actually having HIV is? So, what you can write? Probability of H into probability of T plus given H by probability of H into probability of T plus given H plus probability of now you need to, when under the which cases this is going to be report positive. So this is non-negative and probability of test positive given H. Okay, so will it be sufficient or not? Just think, are we missing anything? Because we are not, when, see, only one thing is, it has given that test is positive. It is given, what is the thing they mentioned? This test is positive, what they have mentioned. So whether it is, do we need to go for any other cases, or these cases will be sufficient? Okay. So do we need to go for any further test? Okay. So if you write this one, so what is the answer? Probability of H is 0.01 into T plus 0.9 by 0.01 into 0.9. Probability of H prime is 0.99, but still it can be test positive is 0.01. So it is equal to 0.009 by 0.009 plus 0.001299. So it is equal to 9 by 123. So it is 90 by, here what will happen? 90 plus 99. Is it correct? A simplification. Just look at the simplification part quickly. Just look at the simplification. I think seems to be wrong. Is it correct? Just quickly look at. So here, just I'll tell you one thing, a small correction I will do here. See, whatever these things are there, no? See, instead of going for P of E, etc., large population of which only 0.1% will have the HIV. Okay, so here probability of H is equal to 0.1 into probability of H. What is the thing you are taking about here? That 9. Yes, somebody is raising the hand. Let me just. Where is he? Yes, Shashivardhan.
Sir, it is 0.001, no, sir.
0.001. Yes,
where, sir. 0.1% has HIV, no, 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 sir. 0.1% has HIV, no
Oh, okay. For probability of 0.1, yeah. So 0.0, okay, right. Correct, beta. So this value will, yes. So it is only having, yes, right, correct, beta. 0.1% means what is the probability? 0.001. 1% is 0.01. 0.1 is 0. Yes, 0.001 into 0.9. Okay, that's right, beta. 0.001 into 0.9 plus H bar will be 0.999 into point H bar. Yes, 0. Yeah, you simplify this one. Okay. Right. This is 0.1%. So it's not 1%. Point not 1. 0.1 means it is 0.001. Right. Moving to the next question. A bag contains 4 balls of unknown colors. A ball is drawn at random from it and it's found to be white. Probability that all the balls are in bag are white. Very important model here. So I'm not sure what type of balls we have, but a ball is drawn from the bag and it is found to be white. Make it fast. Yes. Anybody got the idea? How many of you are getting the idea first? Because it is a little different model. Okay. See, the first thing is, there are the cases. Case number 1, 4 white balls. This is, let me take like event 1 is 4 white balls. So probability of E1, let me write again. Event 2 means the box may contain 3 white and 1 non-white. So whether this is red or blue or green, I just don't mind. Whether it is white or not white. Event 3 is 2 white, 2 non-white. Event 4 is 1 white, 3 non-white. That's it. These are only the 4 events. Now, probability of E is the event of picking white ball. So what is the probability of E when it is E1? 1. Now, probability of E given E2, 3/4. Probability of E given E3, 2/4. Probability of E given E4, 1/4. Now, probability of E1 is equal to probability of E2 is equal to probability of E3 is equal to probability of E4 is equal to 1/4 each. What is required? Probability of, we have to pick the white ball, given that the probability that all the balls in the bag are, so E1. So this is probability of E1 into probability of E given E1 by summation probability of EI into probability of E given EI. So which is equal to 1/4 into 1 by 1/4 into 1 plus 1/4 into 3/4 plus 1/4 into 2/4 plus 1/4 into 1/4. 1/4, 1/4 cancel every time. This is equal to 1/1 plus 3/4 plus 2/4 plus 1/4. So this is 4/4 plus 3 plus 2 plus 1 is equal to 10, is equal to 2/5. Okay. Answer is 2/5. Right. Is it clear? Moving to the next question. Yes. See, some of the questions like using the tree diagram means cases, instead of writing the cases, we'll go ahead. For example, you look at this question. A box contains three kinds A, B, C. Normal kind, A is the normal kind. B is the double-headed kind. C is the weighted kind, so that the probability of getting head is 1/3. A coin is randomly selected and tossed. Find the probability that head appears. So what is this one? So you can select A or B or C. You can select A or B or C. So for this one, head, probability of getting head. So you are selecting a kind. You can select A or you can select B or you can select C. A is head or tail. B is head only because the second one also. Next one is head or tail. So probability of head is 1/2, probability of tail is 1/2, probability of head is 1, probability of head is 1/3, probability of tail is 2/3. So this is 1/3 ways, 1/3 ways, 1/3 ways. So instead of writing these values here, you will write this one. Here, what is this one? 1/2, 1/2, 1, 1/3, 1, 2/3. Now probability of head. So it is, look at here, 1/3 into 1/2 or 1/3 into 1 or 1/3 into 1/3. So this is equal to 18. This is 6/3 plus 6 plus 2, which is equal to 11/8. If I want find if head appears, find the probability that it is normal kind. So here what happened? This is the probability of head. Now probability of A given H. So what is this one? Probability of H on top of this one, probability of A into probability of H given A. So which is equal to 1/3 into 1/6. So 1/6/11/18 is equal to 3/22. Okay? Because 3 ones are 3 6 are. Oh, look at here. 6 ones are 6 threes are. So it is 3/11. Sorry. 3/11. Find the probability that tail appears. Find the probability that tail appears. So tail means 1/3 into 1/2. Here no case, 1/3 into 2/3. So 1/6 plus 2/9 is equal to 18. 3 plus 4, 7/18. Or 1 minus also you can do. If tail appears, find the probability that from the third case. So what is the third case? The third case is 2/9 by 7/18 is equal to 4/7. Okay, so you can go ahead with going for the diagram. It's a cases. So this is specially called it as writing the tree type of thing. So to avoid the confusion, you can go ahead with this one. Without that one also, at the end of the day, we require the answer. At the end of the day, we require the answer in the best possible way. Yes, Sai Charath.
Hello, sir. Just now I was asked to start my video, sir. Why, sir?
No, I didn't. Maybe by mistake it has come. Okay.
Okay. Sir.
Aditya,
Sir, once again explain, sir. Due to net connection, only this.
okay. So here what we are doing is, you have the 3 cases. You have a coin A, coin B, coin C. So probability of choosing coin A, coin B, coin C are equally equal. So this is 1 by 3 ways, 1 by 3 ways, 1 by 3 ways. After this, from A, you may get the outcome head or you may get the outcome tail. So since it is a fair kind, the probability will be 1 by 2 and 1 by 2. Next, from B, you'll get only one head because it is a double-headed. So the probability is 1. Next, for C, you can get head or tail. So what is the thing? Here, probability of getting head because it's unbiased kind. So weighted kind. Head is 1 by 3 and this is 2 by 3. You write the cases. Okay. Sir, is this our last online class? I just don't know. Yes, Shashivardhan.
Sir, yesterday principal sir message was come by Wednesday morning 9 o'clock to evening 6 o'clock, sir. That's why.
Oh, Wednesday. Oh, tomorrow is a Wednesday.
Yes, sir.
Okay, then you have to come. So start coming. Okay.
Sir,
So-
but last week they have said, means when we got phone calls, they said that this week till Friday we have online classes.
Okay. Okay.
The
But
total chaos, sir.
why to wait? If it is unavoidable, that's okay. Otherwise, come now. Okay.
Okay.
So I don't have any such information, but be here. Okay. These many days you are there at home, huh? I don't think there is any homesick or further. I'm sure that you people are eagerly waiting to come over here.
Yes, sir.
So, right. So with this one, I'm concluding today's session and hope you